Here's another problem. This one's also an inequality and it's got some decimal numbers in it, but we still follow the exact same strategies. So what you should notice is that we have two different terms with x in them on one side, and you want to combine those. So you just add 0.4x and 0.6x makes 1x. Okay? So I have 1x plus 0.01 is less than 0.03. All right? And you subtract this to get it to the other side. So x is less than 0.02. And we can graph that the same way. For this one, you might want to also put 0 on your number line. There's my 0.02, just above 0. And it's strictly less than, so I'm going to do hollow circle around. And less than is in this direction. So anything less than 0.02 is a solution, including 0. And here's the next one. Now the trickiest part of this one is this right here. Because it's out in front of parentheses, you need to distribute it. That means multiply it by everything inside before we move on. And I wanted to focus on that to make sure you have good skills with doing this, distributing a fraction. So that's times 15x. I also want to change this to add -5. So then I have add -2/5 times -5/1, which is greater than 4 minus 5x. Okay? We can do some reducing here. So 5 goes into 15 3 times. This results in -6x for that term, plus 5 goes into 5 one time, and a negative times a negative makes +2 right there, which is greater than 4 minus 5x. Okay. Now we've got x's on both sides and numbers on both sides. I prefer to move the x in this direction with an inequality especially, so I'm going to get rid of the one on the right side by doing this. And I need to add 5x to both sides, which leaves me with -1x plus 2 is greater than 4. Okay? And now let's subtract 2 to get it over here. So I have -x is greater than 2. Can't leave -x like that. I've got to divide or multiply by -1. So x, flip that, is less than -2. That's my solution, and you should be able to graph it. So you think doesn't include -2, everything less than that. Let's look at another problem. Find the two smallest consecutive integers whose sum is greater than 35. Okay, so variable expressions for the two numbers. If they're consecutive integers, remember from an earlier video that we're going to use x and x plus 1 to stand for these two numbers, okay, because one of them has to be one bigger than the other, right? And then we need an inequality statement because this says that their sum is greater than 35, okay? So we need an expression that says that. Their sum is x plus 1, and that is greater than 35. Okay? And then you solve that. So I'm going to combine these like terms right here. I get 2x plus 1 is greater than 35. And I'm going to subtract 1 from both sides. So 2x is greater than 34. Now divide by 2. and you get x is greater than 17. Okay, that doesn't solve the problem. That's just solving for the variable in the problem. Now let's go back and see what we're looking for. We're looking for the two smallest consecutive integers whose sum is greater than 35. Okay, so we were looking for x and x plus 1, and we've discovered that x has to be greater than 17. So it can't be 17. X is any number bigger than 17. So it could be 18, right? We're looking for the smallest consecutive numbers. So 18 is the smallest that x could be. So 19 is the smallest that x plus 1 could be. And those should be our two consecutive numbers whose sum is greater than 35. Well, let's check. 18 plus 19 is 37, and that is greater than 35. What if we pick the numbers smaller than that, like 17 and 18? Okay, if you add those together, you get 35 exactly. And it can't be equal to 35, it has to be greater than 35, so this doesn't work. This is the answer right there. Okay, let's try a similar one so you can try out those skills one more time. This one is looking for the two largest consecutive odd integers whose sum is less than 30 or less than 64, so less than 64. Okay? So variable expressions, if they're both odd, then we use x and x plus 2, because these aren't consecutive integers, they're consecutive odd integers, so they're 2 apart. If it was even, you would still set it up the same way. And just make sure that at the very end of the problem, you're talking about odd numbers, not even. Okay, this is very similar now because its sum is less than 64. So you write the sum of these two amounts, x plus 2 is less than 64, and then solve it. So I'm going to add those two together. So 2x's plus 2 is less than 64. And if I subtract 2 from both sides, 2x must be less than 62. And so if I divide by 2, I find that x has to be less than 31. It can't be 31, it has to be less than 31. So if x is less than 31, the largest that it could be is 29. Okay, and if x is 29, then x plus 2 is 29 plus 2, which is 31, and that is the next odd number. So let's see if these work. The sum is supposed to be less than 64. Let's add these two. 29 and 31 makes 60. That is definitely less than 64. Well, what happens if they're bigger? So the next pair would be 31 and 33, right? If you add those, you get 64 exactly. It can't be that. So that is not the solution. It's 29 and 31. Okay, let's try something else.